Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate. In today's video, we are going to talk about hazards associated with the overexposure to solar radiation. Behind me, you see a figure of the beautiful sun from NASA's website. In my previous video, I discussed various characteristics of the sun and how sun supports life on this planet and weather and climate. However, overexposure to solar radiation has certain hazards that need to be addressed. Firstly, overexposure to ultraviolet radiation can cause cataracts in your eyes, and most importantly, can cause various types of skin cancer that we will discuss in today's video. Firstly, what is ultraviolet or UV light? It's a part of electromagnetic spectrum that sun emits, and ultraviolet radiation is high energy radiation. You will remember from my previous videos. It is less energetic, for example, than X-rays and gamma rays, but it is more energetic than the visible light and infrared light. Ultraviolet or UV radiation has three subparts, so to speak: UVA, UVB, and UVC. Let's start with UVC, which is the most energetic out of ultraviolet radiation. UVC light has wavelength between approximately 200 and 280 nanometers. Fortunately, all of this radiation is absorbed in the upper layers of the atmosphere, and practically nothing reaches the surface. UVB radiation has wavelength between approximately 280 and 320 nanometers. Between 97, 98, 99% of this radiation is absorbed by the ozone layer, but not everything, as you can see. And this 1–2% that reaches the surface can cause burning of your skin, issues with the eyes, and so on. And we will discuss today how body protects itself against this radiation and what we can do also to protect ourselves. And lastly, we have UVA, the least energetic of ultraviolet radiation. Wavelength is between approximately 320 and 400 nanometers. Now, most of this radiation reaches the surface. It's mostly harmless, but in combination with UVB radiation, it can cause damage to your skin, such as premature aging of the skin and so on. Now, as you can see, therefore, ultraviolet radiation as a whole is between approximately 200 nanometers and 400 nanometers in terms of wavelengths. Some other books or videos can give a slightly different range, but that's not so important. Now, let us see how our skin protects itself against exposure to ultraviolet radiation. Here is a schematic of the upper layer of our skin. So let's first start with this layer over here at the top of the skin that is known as stratum corneum. This is approximately 20 dead cells at the top of the skin. Now, this whole region of the upper layer of the skin is known as epidermis. And the bottom of the epidermis region is the basement membrane that you can see here that separates upper region of the skin with the deeper layers of the skin. Now, right above the basement membrane, we have basal cells that sit here, as you can see. These basal cells divide, creating other cells or creating more basal cells. So as I said, some of them divide and start migrating to the top of the skin. Those migrating cells are known as squamous cells, and these are all these cells that you see here. As the squamous cells migrate to the top of the skin, they die off, ultimately forming stratum corneum, as I said, layer of approximately 20 dead cells. And you can even see this layer. When you scratch your skin, if it is very dry, you will see basically dead skin being peeled off. It takes few days to weeks for these squamous cells to migrate from the basement membrane all the way to stratum corneum. Lastly, you see here there is this purple cell over here, and that is indeed melanocyte. Melanocyte is a cell that produces organelle that we know as melanosome, and that organelle is here indicated with these small dots of yellow and black. And these black pigments are actually melanin that we are all familiar with, at least from media. Now, when we know this basic anatomy of the surface layer of the skin, how does our skin protects our body from ultraviolet radiation? Well, the first layer of protection, sorry, I have to adjust my computer. The first layer of protection comes from stratum corneum. When the ultraviolet radiation reaches our skin, some of it is absorbed by these dead cells at the top of our skin. So that's the first layer of defense. However, stratum corneum, or these dead cells, do not absorb everything. So some of the solar radiation is transmitted down through the skin, and some of it reaches basal cells. Now, our organism has a trigger, so to speak, that when ultraviolet radiation reaches basal cells, it accelerates their division, which means we will have more squamous cells traveling to the top of the skin, dying off eventually and forming thicker layer of stratum corneum. So that's the second form of defense. More dead cells forms on the top of our skin, and therefore more dead cells absorbs more ultraviolet radiation. And finally, what you were all expecting, the final protection comes from melanocyte cells. Melanocytes start producing more melanosome organelle that contains melanin, and that is distributed, as you can see, across squamous cells, because melanin is very efficient at absorbing ultraviolet radiation. Most of that radiation is absorbed by melanin, and our skin becomes darker because melanin is a dark pigment in melanosome. Now, of course, it is very important to understand that melanin is not ultimate protection against ultraviolet radiation, and it cannot absorb 100% of UV light. So, even when you tan, and if you have darker skin, you are never 100% protected against skin cancer, against damage to your skin. Now, there are three types of cancer associated with these three types of cells. So we have basal cell carcinoma, squamous cell carcinoma, and malignant melanoma associated with melanocyte. As always, cancer is associated with UV light damaging DNA of these cells. Let us start with basal cell carcinoma because it is the least aggressive type of cancer. It attacks basal cells. It takes many, many years to develop. And if detected in early stages, it has a very high chance of being successfully treated. It rarely spreads to deeper layers of the skin and to other parts of body. Approximately 70% of all skin cancers are indeed basal cell carcinoma. The other type of skin cancer is squamous cell carcinoma. That one is more aggressive than the basal cell carcinoma. It has much faster progression and more chances to spread to deeper layers of the skin and other parts of the body. It usually forms on face, ears, neck, lips, and arms. And these two types of carcinoma are usually detected as some sort of abnormal formation on your skin or some sore that just doesn't go away. Squamous cell carcinoma is approximately 20% of all skin cancers. And of course, by far, the worst type of cancer is associated with melanocytes. In this type of cancer, DNA of melanocyte is damaged and the cells start producing abnormal amount of melanin. So these types of cancers usually form around torso and legs, and they are usually first observed as extremely dark localized spots on your skin because, as I just said, melanocyte is producing abnormal amount of melanosome that contains melanin. These types of cancers are most aggressive. They spread very fast to other parts of the body, and in many cases, unfortunately, treatment is not on time to save the patient. These types of cancers, malignant melanoma, are only 5% of all skin cancers, yet they cause over 90% of deaths associated with skin cancer. So to protect our body, in addition to natural protection, we should be aware of solar radiation, and we should not go out when the exposure to ultraviolet radiation is very high. And for that reason, there are various indices that were developed to indicate the level of exposure to ultraviolet radiation. Here is a little bit busy table, but let's go through it. We have index value. This particular index value is proposed by researchers in the United States, and that is the US UV index and minutes to burn depending on the sensitivity of person's skin. So UV index goes between 0 or 1 sometimes to 15. 15 being the highest value, and then qualitatively we have exposure category of low exposure to ultraviolet radiation, moderate, high, very high, extreme. And in these two columns we have minutes to burn for most susceptible skin type, which are pale, bright skins, and minutes to burn for least susceptible skin phototype, and these are darker skins. So you can see, for example, if the value of UV index is 7, that corresponds to high exposure category. So if you have susceptible skin, you will burn in approximately 8.5 minutes. If you have least susceptible skin for UV radiation, you will burn in approximately 40 minutes. And then you can take a screenshot of this and check what would be your susceptibility depending on your skin type. On this slide, we have this UV index forecast. I'm recording this video on May 17, and this is forecast for tomorrow, 18 May 2024. You can see, for example, in the United States, southern part have extreme values of UV index 10, 9, 11, and you can see here that 10, 9, 11 is very high to extreme. So if you have susceptible skin, you will burn in approximately 5 minutes if exposed to solar radiation. If you have the least susceptible skin, you will burn in approximately 25 minutes or so. So the question is, where do we usually burn? Well, of course, we usually burn on the beach, and there are reasons for that. First of all, we spend a lot of time on the beach and we are exposed to solar radiation. But there is more than that. Even when we are under umbrella or some sort of protection, we can still burn because sand reflects approximately 50% of ultraviolet radiation. Furthermore, water reflects almost 100% of solar ultraviolet radiation. And you know that if you are on a boat, you come back home, you burn more than if you were on a beach or somewhere inland. You ask yourself why. That's because you are burning from sun directly hitting your skin, but also ultraviolet radiation is reflected from the surface of the water and then again burns your skin. You might say, what if I jump into the water? Not much better, because what is not reflected by the water of ultraviolet radiation gets transmitted up to approximately depth of 1 meter. So if you're floating on the surface of the water, you know that your shoulders and arms burn. You experience that because your shoulders and arms are either out of the water or 10-20 centimeters under the water, and ultraviolet radiation penetrates those depths. Another location where you are where you can be severely exposed to ultraviolet radiation is when you are on the mountains, higher in the atmosphere. If you are at 3,000 meter height, then your exposure to ultraviolet radiation is approximately 40% higher than when you are at sea level. So try to be in shadows and try not to go out around noon, at least between 10-11 a.m. local time, your local time, and perhaps 3-4 p.m. local time. And lastly, we can protect our body from ultraviolet radiation by having sun cream. Sun cream selectively absorbs ultraviolet radiation, and there is sun protection factor, SPF, on the bottles with sun cream. What does that factor mean? That factor is a multiplier for the minutes of time that you can be safely exposed to ultraviolet radiation. So it is relative to your skin type. Let me give you an example. Let's say you burn in 10 minutes. If you put sun cream with sun protection factor 10, then you will burn in 10 minutes times 10 that you get protection from the sun cream, so in 100 minutes. If you burn in 20 minutes naturally and you have sun cream with the sun protection factor of 20, then you will burn in approximately 20 times 20, 400 minutes. You should also keep in mind that many sun creams say they are water resistant and they cannot be washed out by water. You should not trust that 100%. Everything is washed out by water. So if you go into the water, it's better to change sunscreen, put new layer of sun cream more often than you would if you don't go into water. I hope this video helped you understand hazards associated with the overexposure to ultraviolet radiation, and you can make better decisions when you go to beach, water, and so on. I am not a medical doctor, so if you want professional opinion, you should always seek it from a medical doctor. I'm speaking from the point of view of an atmospheric scientist that is knowledgeable of weather and climate. Until next video, goodbye.